Alright, let's say the growth rate of a population is given by R of t equals 600 times 2 to the 0.7 t people per year, where t equals 0 represents the year 2001. The growth rate takes into account births, deaths, and all those leaving or joining the population. What is the change in population from 2001 to 2007? If we were to graph this function R of t, it would start off at an initial value of 600, and then it would grow exponentially from there. That's R of t. Now t equals 0 is the year 2001. This is the calendar year, but that corresponds to a t value of 0. And then they want us to go all the way to 2007, which is actually 6 years after 2001, so t is 6 for that. If we were to calculate all the area under the curve, that would represent the total change in the population. It could be called delta P. The population has its own curve, which is an antiderivative of R. If we were to sketch the population, it would also be some kind of exponential graph. But what we're trying to find is we're trying to see how much does the population increase. That would be what we're finding, which is delta P in this case. Alright, so let's write the integral. Delta P is going to be an integral from t equals 0 to t equals 6 of R of t dt. So it's going to be going from 0 to 6 of this function 600 times 2 to the 0.7 t. Alright, now solving this is going to require u substitution. So one thing we know we can do is pull the constant 600 out front. So that simplifies it a little bit, but we still have this 0.7t, which is complicating the situation. If we had an antiderivative of, say, just 2 to the t, then the antiderivative of that would be 2 to the t over ln 2. And so if this part were to just be a variable, then we could solve the problem. And so that's what we want to do here, is we want to let u take the place of the 0.7t. Right, so that's going to give us 600 from 0 to 6, and we'll put 2 to the u then in place of that. But we still need to get rid of the dt. We have to put it in terms of du. So let's differentiate this statement here. Du over dt is 0.7. Therefore, by multiplying to the other side, we get that du is 0.7 dt. I would now want to solve for dt and get this, so that I could now take that result and put it in place of dt in the formula here. So we're going to get 600 t equals 0 to t equals 6, 2 to the u times 1 over 0.7 du. Okay, so this could now be solved. If I pull the 1 over 0.7 out, then we're going to be left with this. Now my limits right now are not matching the variable of integration. That won't matter so much though, because I can make it clear that these aren't u values, they're t values. And I won't plug them in until I get everything back in terms of t. So first, let's write the antiderivative. This is going to be our antiderivative of 2 to the u. Then I'm going to put the limits in, but make it clear that they're not u values. Now I'm going to substitute back in what we originally let u represent. It represented 0.7t. So we have to put that back in now. And now I can bring back those limits and we can finally plug them in to solve. So we'll get 600 over 0.7, 2 to the 0.7 times 6, and then we'll have 2 to the 0.7 times 0. And let me just put that into calculator here. 21,491 people. So that should be the change in population from 2001 to 2007.